Welcome back to another chapter in a developer's guide for Windows 10 Insider Preview. If you're building a Windows application, you might be wanting to make an application that uses more than just is available on the desktop. Maybe you want to reach out and get data that's out in the cloud. Lucky for you, that's this session.
It is, and this is a chapter in our long story, and this is the crux of the whole. No, it's not.
This is the meaning of it all.
Well, we did a session called Connected Experiences, which was like setting the scene for this. It was about making sure we're giving you these great tools to allow you to build apps that will run across loads of different devices. So if a user's running your app on their phone and also their tablet, and then they go and pick up their PC, throw it at the wall. No, they go on their PC and start running your app. You want to make sure that you have a connected experience across all those different devices.
Right.
And a good way of doing that is to make sure you put a cloud backend, so your mobile app is backed by services in the cloud that will allow you to, all the apps on all those different devices, to get the current state of the data of your app.
So we're going to talk about Azure using app services so that you can interact with your SQL database in the back using Azure as your store. We'll also talk about just the basics of interacting with REST services, as well as an introduction to authentication.
Yep. So, this really, mobility and the cloud is really the new normal situation. We employees using their personal devices for work, and then businesses rolling out their own services to support work, Many employees, of course, are now frequently are not desk-bound anymore. They're working away, working from home, working at different offices, hot desking, all this kind of stuff. Really is. Mobility in the cloud is the new normal. These kind of working situations are all enabled by having that data, that state stored in the cloud. And we need to look at how apps can do that sort of thing. Right, so to set the scene for this, let's look. Speaking about networking in a broader sense, the UWP API set offers a lot of stuff, a lot of services, and really when you want to start thinking about how you want to make use of the cloud and networks, the key thing here is to think about mobile devices, tablets, phones, and that sort of thing are not always connected, and people kind of forget this. Mm-hmm. Especially those of us who are working for large companies in cities which are well connected. It's kind of easy to forget that sometimes you cannot really take connectivity for granted.
That's right. You could be in a tunnel.
You could be
on a boat.
Yeah, and we all know if you go to a big tech conference or something, you get a few thousand geeks all together, and they're all armed with 3 devices. Wi-Fi networks can start suffering, and cellular networks can start suffering. So you just really have got to always think about your usage scenario for your app, and what are you going to do if you haven't got a network. So any solution that uses the cloud, caching is also important, making sure that you can handle these outages and the storing state on the device, work disconnected, and then resume when you've got connectivity again, sync everything up and make sure that the whole thing keeps running.
It's a frustrating experience to open up an application and have it a spin while it's loading before you get to interact with it at all, when you know that you can interact with some of the data that you'd already gotten in your previous session.
That's right, yeah. And there's other things we can use. We're not covering it in this session, but think about push notifications. You could send a notification from the back end, and that could be used to trigger a background task. And that background task could then pull some stuff from a cloud service and store it locally on the device. So the next time the user launches your app, the data, up-to-date data is already there, and the app launches fast, and they get a good user experience. These are the kind of things you can think about to really delight your users.
Oh, that would have made a great wisdom slide, actually, where you can use push notifications to kind of shake your application awake and refresh your cache. That's pretty nice.
We'll do that in the next revision, huh?
Oh, yeah.
Yeah. Right, anything to do with networks, there's just some capabilities you need to declare, so just a quick reminder here.
That's important because I think a lot of developers get this as a gotcha. They're trying to interact with their service and it doesn't work, only to realize that the capability's not there. But I did notice in Visual Studio 2015, the internet client capability it defaults to on now.
Right.
You don't have to go ask for it.
That's right. That's if you do a file new project, that is already in the manifest. You get the internet client. So
connected clients are the norm.
Are the norm. That's right. Yes. And you know, when you're calling APIs in UWP and you haven't declared the right capability, unfortunately, you don't always get an exception that says, "Dummy, you haven't declared the capability." It would be nice if it did.
Even if it said dummy, I would like it better. That you chase these things around only to find that, oh, it's that. Yeah, that's right. Of course, adding capabilities right now, there's no UI inside the project, inside Visual Studio, but that's coming as we get closer to RTM.
Yep. Right then, let's think about how are you going to make use of networks? How are you going to call cloud services and do all this kind of thing? Well, you know, if you're a geek, you might have this tendency to kind of get right down in the weeds and want to code everything up right from the bottom up and build your own internet. This generally is not a good idea. Use these, you've got all these services that make it easy for you to build connected solutions. So make use of them, because there's other people who have done the work to create a resilient backend, and you can use those services and create a great solution. You don't have to build everything from scratch. So use Microsoft Azure App Services.
You almost said mobile services, because this really is the rebranding of mobile services.
Yeah, so we announced this at the time we're recording this, just after build. It's about a month ago that we announced the rebranding of what was formerly Microsoft Azure Mobile Services, and it's now called Azure App Services, and it's part of Microsoft Azure, I always get this wrong, Microsoft Azure mobile apps within Microsoft Azure App Services.
That's it.
It. Yeah, so Azure App Services.
Work. Navigating that's impressive, I must say.
Yeah, I struggled there for a minute. So Azure App Services is a bundle of services. So you get mobile apps is in there, which was the older mobile services. You get API services, which is a cool way of building a REST front end for some kind of API that some service.
With authentication and everything?
Oh, yeah, that's right. It's also got a websites in there. So the old Azure websites is in there as part of this. And they all run within the same context, so you can easily build integrated solutions that tie all these things together.
I feel like these teams must get paid by the feature. They add so many features.
They are
so fast.
Innovative. It's just a tidal wave.
You had talked about push notifications. So I see you have the Azure Notification Hub. This is a great variant on the notification on Windows Notification Services. It's an umbrella that includes WNS, but also includes the ability to send push notifications to other platforms like Apple and Android. Very cool.
And actually, that's true of Azure App Services as well. So the mobile apps in Azure App Services supports all the different clients as well. So all of these services are designed to support clients from different vendors.
We had talked about in background execution, our module that we did previously, how you can have background tasks doing things even when your application is not running. That's where the background transfer task comes in.
Yeah, this is cool. So if you want to download or upload files, yeah, sure, you could write some low-level code to do all that. But then, you know, what happens if your app gets suspended halfway through and all that? Yeah, it
interrupts your download.
Yeah,
what
that's
a terrible
right,
experience.
Yeah, that is a bad experience. So actually, there's a wonderful service called the Background Transfer Service, where essentially you just ask the platform to do it for you. Mm-hmm. You queue up a file upload or a file download request, and if your app gets suspended, it doesn't matter, because these requests are managed by the platform. They're persistent, so you know you could reboot the whole device.
Right, Windows does all the work for you.
Just does it for you. So that's a really cool way of doing that. We haven't got time to look at it, but there's plenty of samples about that.
Sure.
And then there's the whole authentication thing. You could do low-level HTTP to do OAuth 2 authentication, but don't do that. We've got the Web Account Manager APIs that help you do that.
That's right.
But if you really need to get down and do HTTP calls, gets, posts, and the rest of it, well, we've got obviously the HTTP client.
The brand new HTTP client, just introduced in Windows 8.1, I think. All right, let's talk about Azure, because I think starting with mobile services might be the easiest place for most developers to start. So if we see it, they'll fall in love with it.
Yep, that's right. So just got a couple of slides to set the scene. So this shot is of the new Azure portal, which is in preview at the moment. It gives you a UI for creating mobile backends and everything else in Azure as well. So the mobile apps bit in Azure App Services allows you to build and host this backend for any mobile app, and you can see the list of clients there for iOS, Android, Windows, of course, HTML5, Xamarin clients. And they have great tutorials that walk you through connecting up your app to this backend service.
They do a to-do list too in all their samples.
They do. In fact, I'm going to show it in a minute. It would be nice to have done ours, but time didn't allow. So we're going to look at their sample. It also has great support for enterprise single sign-on through Active Directory, or you can easily build in authentication against social networks for that sort of thing. Obviously, partition the data that's stored up in the cloud. The data can be stored in SQL Azure or even in other databases like Oracle, MongoDB, that sort of stuff.
I could even use blob storage if I wanted to.
You could, yeah, that's right. And you can easily link it to your through to your on-premises servers and services as well. Is a secure way of tunneling through to your own premises. Auto scale this scales to like millions of client devices. And best of all, you actually get an enterprise-grade service level agreement with this. This is a really serious solution.
Developers who are interested in it also have the option of just trying it for free as well. There are tiers in the app services that you can go in, and you can build really a quite significant application with a lot of functionality before you even hit a pricing tier at all. It's pretty cool. If you're an MSDN subscriber, then you get a lot of Azure credits right off the bat as well. So a lot of easy ways to start and kind of playing with Azure and get it into your app before you have to consider what this is going to actually be as far as cost.
That's right. So in the portal, you get a nice wizard that takes you through creating your mobile backend. It may be that when we get to RTM, in Visual Studio 2015, you'll be able to create your app service from there. I'm not sure about that because at the moment everything's in preview. Currently, certainly the bits just after build, that capability is not there. So we're on the portal to do that. I'm going to run you through this in a minute, so I'm not going to kind of dig deep into this.
Okay.
And then you've also got these neat little things where you can download sample code straight off the bat, a working sample. You can download it and use that to either you can connect an existing app. It gives you step-by-step or the simple code steps you need to connect your own existing app to your Azure mobile backend, or you can download a whole self-contained sample, which at the moment, well, I'll show you this in the demo. I'll show you what happens.
We're also wondering what it's going to be. Some sort of surprise coming.
Yeah, and the way, yes, indeed. Now, the way you interact with data tables that are actually hosted in the cloud in Azure, when you integrate your app, you basically get this iMobile service table. You get a client API that you can use to get at tables. You get a reference to a table that's stored up in Azure. And then you simply new up items or download or get items from within that table. You manipulate them in code, and then there's a whole bunch of methods on the table object which allows you to do the basic CRUD operations: create, read, update.
So you interact with it like an ORM, right? It feels natural, and when you say go get table using the client, even though it's in memory at that moment, you really have a gateway or proxy into interacting with the actual database that's sitting up in the cloud.
Exactly so.
So this isn't a wrapper around SQLite, not yet.
Not yet. Well, I'll come on to that. That's an interesting point. Because there is an offline sync feature of this, which is where it gets really exciting. And so there's many features, including that offline sync, where it does in fact use SQLite on the client device. And again, this SQLite was chosen because it's open source, and this does support, as I said before, iOS, Android, HTML5, and Windows. So SQLite is a perfect solution for that because it's available on all of those.
So this is that offline sync support that you're talking about.
Yeah, that's
okay,
right.
I got you. Very cool.
And a bunch of other features. Obviously, the authentication I already mentioned, partitioning data. You can build into the back-end additional server logic and scheduled background tasks and call out to your own back-end services as well. So it's very flexible and a great way of building a robust cloud back-end for your application.
Let's look at it.
Yeah, let's do that. Okay, it's quite a long little demo of this, but here I am in my Azure portal. Let's create ourselves a new mobile app. This is in the whole Azure Apps thing. So you give it a name. So this is the back end. So it's going to create a database and a REST service. Now this is the database. You need to either you create a new database, or I'm actually going to use one that I've already used before over there. Test MVA mobile app DB.
Copy a Northwind.
It's not a Northwind. No. Put in my server the administrator password. OK, that. And then these leaves of the UI unfold. And then we just create. And this will go away, and it's doing magic in the cloud.
It's amazing how quickly it provisions.
This will take, well, no, it's not provisioned yet. So it's down there on the bottom right. It's doing that little logo. It's doing all sorts of clever stuff. So it's setting up the database. It's setting up the push notification hub.
Yeah.
Use notification hubs for push. It's setting up the REST API to allow you to interact with the whole service. So there's a whole bunch of stuff going on, and it's rolling up virtual machines in the cloud. And then, right, here we go.
Not so long, really.
Not so long. And then here we go. Then you get all the details of the URL for your service, the gateway, lots of stuff that you probably don't need to know, because up here, this is where you kind of really get started. You see all the different clients there, but this is the Windows one. You can create a new app, or you can connect an existing app. I'm just going to create a new app. Well, actually, there's two downloads here. So first of all, this is the .NET code for your backend. So let's just do that first. We'll download the code for your server project. So we're going to, where should we put that? Let's go and stick down here into my demos folder. We'll unzip all that in just a second. Here we go. Unzip that, and then it's just a Visual Studio solution with the web API, an ASP.NET web API backend for your service. And you can obviously manipulate this if you're putting in custom logic. This is where you would work in this project. So it's, for those of you familiar with web API, all the MVC, ASP.NET MVC structures in here, all the stuff, but I'm just going to build it. It builds straight off the bat. I don't need to do any coding on it. It's restoring a gazillion NuGet packages.
That's a lot.
Yeah. Build it twice. That's my hot tip. Build it 3 times. Build it twice. It doesn't quite work the first time at the moment, but then second time's the charm.
They need a button that pops up that says, "Are you sure?"
Yeah, that's right. Now, this is publishing it. So you select Microsoft Azure Web Apps. I need to just sign in with my Microsoft account credentials.
Very good.
I'm not going to tell you what that is. And
now,
then,
this is your Microsoft account credentials associated to your subscription.
For my subscription to Azure, exactly. And then you're looking for the name - code of your service that you just created. And it pulls down the connection, the published profile. You can just validate that that's correct.
Oh, it does all that work for you.
It makes it really easy. And then we're good. Now publish. And now this is publishing up to the cloud. It's all .NET code. Like I said, in time, you will obviously want to modify that. But it's got everything you need to get started. So
that's my web service.
This is the web service. So that's still just publishing up to the cloud. And then just to confirm that it's done, yeah, you get a nice web page.
There's smiley face.
Web service up and running. Yeah, pretty, huh?
Azure websites, it's the happiest place on virtual Earth, Andy. Nice.
Okay, yeah, so that's the back end. Now then, what we're going to do now is think about the client app. So let's download this canned solution, which is going to contain their version of the to-do list, not ours. Let's extract that.
CS, written in C#, it looks like.
Yep, that's right.
It's really nice.
This is the only problem with this, if you like. Let's open it. Is at the moment, there isn't a UWP client. So what we're getting here is an 8.1 universal project with a phone and a desktop head in it. Nothing much happening at all. There we go. Right, and what I'm actually going to do is just do a quick porting of this to UWP. Now, we've got a module all on this altogether. So what I'm going to do is, I'm not going to talk too much about this. Remove the Windows head. We're going to just move all the shared stuff up into the phone head. So I'm just turning it into a single project just for phone at the moment. Get rid of the shared project. Don't need that anymore. And there's other ways of doing this, but this is just for this purposes. Now I'm going to run our little conversion utility. So I'm going to go off and run a command procedure, which is just going to do the project file conversion and the manifest conversion to make this a UWP.
Because there are a couple of XML elements that need to be shifted around inside the proj file.
There's a few bits and pieces, and this is basically a PowerShell script that does all that for you. Right, now we're in Windows Universal land. So you can just rename the project just for completeness. And now we've got a UWP app. like I said, we've got a whole module on this. It's not usually as simple as this.
It's a cool sneak peek into porting.
Yeah.
And
now
how
here's the first
simple
thing.
it is.
Any CPU, we don't like any CPU in the .NET native world, unfortunately. So now I've just switched to x86, and this will, if the gods are smiling on us, will run just straight away.
And they are. We've had an excellent experience so far.
Yeah. Now here we go. This is the to-do app. This is the initial connection to the mobile service client. So let's run this straight away, and straight off the bat, this will connect to our Azure backend. It gives you a couple of items out to get started with, the first item and second item. Then we can create a new to-do item. We're going to call it the MVA dev item number 1.
Number 1, this is the best one.
Yeah, that's right. And we could do another one and another one.
Nice, very nice.
Yeah, so now we've got 4 items, to-do items in our data collection, and we're going to close that. Where is it stored then? Where do you think it's stored it?
On a file system, maybe?
Well, you might, no, that wouldn't be
In
useful.
memory?
So here we're now starting the phone emulator. Now there's no tricks here. This is a completely separate virtual machine. It's a separate computer.
Yeah.
So it doesn't share any shared storage. But look at that, straight off the bat. We've
It's
got
obviously not a
items.
file system,
No.
obviously not in memory.
So this is connecting straight away to Azure and getting our data down. And that's a good start.
That's a heck of a demo right there.
And there's another 5th one just gone on there. So that's good. Now, next thing I want to
We have to be the first to demo this as a UWP.
I think we probably are. Okay, so now the next thing I want to do is add a little bit of offline support to that. Okay, so adding offline support is really easy, as it turns out. First thing we need to do is easy.
Yeah, it didn't take you long at all.
No, so we need to add a NuGet package. Let's go and search online for everything Windows Azure related. Windows Azure.mobile services is the kind of route.
I like this new NuGet interface.
Oh, it's great. And then SQLite Store is a pre-release. So the SQLite Store, we add that to our project, accept the license agreement there. So we're adding, what it does is it thinks it's adding it to Windows 8.1. So it adds the libraries, and it also adds a reference to the SQLite for Windows Runtime. That's no good. Delete that. So we need instead to add a reference to the correct one, which is the SQLite for Universal App Platform. We had a SQLite session if you want to find out how to get hold of that. So look at that. Now then, so that's the kind of support we know, the library support we need. What about the code? Well, it just so happens that our sample that you download from them has it all built in, and there's not many code changes you need to make. First of all, a couple of using statements. Then, instead of the mobile service.get table, it's a mobile service.get sync table, which is a slightly different one, which understands offline. Sync. Then, every time you make a change to an item in your model, you just need to call sync async, or at suitable intervals, to sync it back to the back end. And then this is the main bit of the intelligence stuff in there, where you're initializing your local SQLite store, and then this is the sync async method, which is a little bit basic as supplied. So we've actually got a better version that's got a little bit of error handling in that, which is recommended so you can figure out when it doesn't quite work. Now then, oh yeah, one there, I missed that one. So let's put that one in as well. Okay, that should do it, and then we can build and run this. Build it. Check everything is good, and that's succeeded. Great. And then we can go ahead and have a look on the emulator here. And I'm going to use, there's a nice feature where you can actually disable the network. So we're going to put our emulator offline.
You're offline. You're in the tunnel.
Yeah, we're offline. We're in the tunnel. Now let's run the app on the phone emulator. So we're offline, remember. And so now then the app will launch. And it will, it's popped up a message because it was trying to refresh against the server, but it couldn't do. But you can still use the app. Now, obviously, you wouldn't put a message like that. So put the thing in there, we're offline. So this will be cached and synced later. Save that to-do item. Again, it tries to sync. So, but it's in the cache locally.
Oh, that pop-up was just saying you were offline.
Yeah, that's just, it's just this app does that. You wouldn't, obviously, you have a UI like that for a real app. So now we've stopped that, and then let's go and have a look over into our Azure portal, and we can go and have a look in the properties. You can go and find out go and connect to your SQL database. This is the back-end store in the cloud.
Look at the raw data.
We can open in Visual Studio, so we can actually go and have a look at the raw data that's currently in the cloud. There we go. That leaf comes up and allows you to launch straight off into Visual Studio, and it will churn away for a little while, and then we'll give you, open in the SQL Server Object Explorer, a connection directly through to our database. And there it is. It's just refreshing the tables, and in that tables, when it's finished refreshing, there will be our to-do items and a bunch of other sync tables. So this is the to-do items one. Let's view the data in there so we can see what currently is in the cloud. Try again. It's taking a little bit of a while. There you go, it's opening it now. And here we are. Now we can see the data that's currently in the cloud. And that's how we left it at the end of the previous bit before we added the offline support. Async through Azure being the last item.
Not your offline version.
Now let's put our emulator back online. Run the app again on the emulator. And our app will launch. And the first thing it will do, we'll try and synchronize both ways with our cloud. So in a minute, there we go. All of our items have come back through including at the top one, which is the one we entered when we were offline. And let's just refresh that over on Azure just to confirm that the other item that we entered while we were offline has also entered through. And there it is, we're offline, so this will be...
Oh, nice. So this is just calling that sync async.
Yeah, and that's how easy. You just change the to-do item table that you're calling, and it's great. And that's an awesome way of adding offline support to your mobile app.
Brilliant. I like it a lot. Like it a lot. That adds a lot of good functionality and things that are built into to Azure for us. I like that. Okay, so we are looking at Azure, but now let's kind of turn our gaze away from Azure and talk about other aspects.
Yeah, so that's all great, and these kind of back-end as a service and all the client APIs make your life easy, but there are times where you're going to want to do raw HTTP calls, and we have a great API for that, the HTTP client API.
The HTTP client is, if you're a .NET developer, you're probably accustomed to the web client, perhaps. That's been around forever.
Yeah, we haven't got that in UWP.
But you don't have that in UWP, or an older HTTP client from another namespace.
It's the system.NET HTTP client.
And that was written for .NET. Yeah. And so it really wasn't a cross-language option for everything that was building, every language that was building on a Windows app. So now that has been taken down out of the system namespace and moved into WinRT. So now we have that across everything, but it's a new implementation for us.
It does have a new,
fully asynchronous as well.
And it's fully asynchronous. So the API, the methods are not quite the same as the system.NET, the .NET version. So this is the highly performance version. Here's a simple example where you new up an HTTP client. You can set some request headers on it. So in this particular case, we're telling the server that we would quite like it to send us JSON formatted data, please. So that's
You're saying optionally because some servers just return that.
Yeah, actually what I mean is optionally, you can optionally set headers. We could have just called the service and received back whatever it wanted. So.
Right.
But that's the code how you do it. And then you could just call, in this case, the get string async. There's a whole bunch of other methods on HTTP clients. So in this case, we're expecting a JSON string back. And then you specify the URI of the service, which you will recognize looks like our old friend, the Northwind database.
I do recognize.
Yeah, this is confirming what you were saying about resolving the correct type. So actually, you can use system.net.http in UWP apps, which is the older one, or the newer, more performant one is the windows.web.http client. So it's a little bit confusing, but in general, we recommend you use the windows.web version, unless you've got a real reason, maybe you're bringing some code forward from some other app that you created in the past that used the system.net version.
It would be an app from the past because a modern Win32 app can now use these APIs if they want to instead.
That's right.
Yeah, so this is where I would take my application for sure.
dig a little bit deeper into this, there's very simple usages like the previous one I showed you, but if you really want to get at the full response and start digging into cookies and headers and response codes and actually get right down into the detail of what you've been sent, then there's variants on the ways you can call it. And here we've got an example of calling get async rather than get string async. And get async returns the whole thing, and you get the full HTTP response message object, the structure of which is shown in that rather fetching purple block on the right-hand side.
Fetching.
It is fetching. This is how you can read response headers. So if you want to find out the actual HTTP headers the server has sent you, you can do it like that, nice and simple.
This can be important for authentication, specifically custom authentication.
Yeah.
Standard authentication, the client handles automatically, so you don't have to deal with the headers directly.
The writing request headers, there's a whole bunch of them. We already saw an example of adding the request header for saying I wanted JSON content, but there's a whole bunch of these on the right there that you can manipulate the headers on your request, the one that you're sending from your app to the back-end service. So it's very, very flexible, and you can do all sorts of stuff. This is where you can actually send other kinds of a delete request. So there's also, HTTP has all these different verbs on it. So we tend to think of it as getting stuff, but obviously you can post, you can delete, particularly interacting with REST services where at a low level where you are using these HTTP verbs to indicate to the back-end service how you want to handle the particular call to the collection on the back-end.
This makes it so that when you interact with web APIs and the REST implementation, you can start using these different methods, but also like OData, something sophisticated, you can start passing these sort of database operations to it.
Exactly, yes. And speaking of OData,
yes,
I've actually got a demo of an OData.
Excellent.
Yeah, we're only going to do get, so nothing too ambitious, but and also this is for those of you who've seen me speak on this and similar subjects, may well recognise this demo. I have used it before, but some things are too good not to repeat.
Wow, this is a classic.
Yeah, it is a classic. A new version of it. It's a UWP version of an old favourite. So this is a OData service for the Northwind database, our old friend. So you can easily go in and get all the suppliers just by changing the URI. So we're in the browser at the moment talking to our backend service, which is actually on localhost, but
it's all XML.
Yeah, you get the products. You can get the specific product. So here's the second product in the products collection, and you can find the supplier of it. So it's very flexible just by, well, I could even spell it right. Hang on, what's it? You see all this other stuff you get. You actually get the links to navigate to related tables. So it's actually supplier, products to supplier, not suppliers. Now we get the supplier of that product. So very, very flexible with OData, and you can manipulate, you can get at this. Now this UI, I've got 4 buttons, which are going to call this service in 4 different ways. It's exactly the same. I'm going to use HTTP client every way. The first one is just doing a vanilla call to northwind.service/supply. So we're going to get the supplier's data using the default payload format that it sends back to us. So let's do that. And we're seeing the size of it. And actually, in each case, I want to have a look at it. This is the atom feed format.
Kind of a verbose XML format.
Verbose XML, yes. And each case, we're looking at the size of the payload, which is 28K. Now this one, we're setting the request header to ask for it to send us the JSON format from our OData service.
Love JSON.
So the service supports both of these, and we can get, this is what it looks like. This is JSON, which is more compact, but we've still got all that cross-reference link stuff in it. All this allows you to navigate, a lot of extra stuff that may be useful to a client, but pads the response, 15K there. Now this one is just application. See, that was the OData equals verbose. This is the slim JSON response. So this doesn't have all that cross-reference stuff in it, but you do get just the raw data suppliers. So we're still getting the same data that we're interested in.
That's nice. That's very appealing.
But it's 8K now. And now this final one, well, this is how you can use an HTTP protocol filter to ask for compressed content. Now, I've fixed it a little bit so we can actually see what it likes. The server actually sends that to us as well. And the zipped content is 4K. Now look.
Good gravy.
But look, the message is clear here. Look at the different size of these payloads. So think about a mobile app running on a mobile device, maybe on a poor quality network. You want the supplier's data from your service.
Yeah.
Well, think about that. You could just be a lazy developer and ask for it in atom feed format, which would work. Or you could ask for compressed JSON, and you can drop the payload of this relatively small amount of data from 28K down to 4K. It's great for user experience. They get a good experience. The network calls complete faster. It will work on a poor quality cellular data connection.
Obviously, you're going to hydrate these into classes anyway, so your experience from a development point of view is going to be identical. It's the user's experience that's improved from this.
Exactly. And this is delighting users is what we're about.
That's pretty cool. It zips it on that side and compresses it, and you get to unzip it.
Yep. Yeah, well, it's handled for you. So this HTTP base protocol filter will pop up. It's very useful. It's useful for a number of things. Here's an example of using it to get at cookies, or setting cookies. So you can send a cookie along with your HTTP request onto the other end.
Some sites require that.
They do. So that's one usage of this HTTP base protocol filter. And this is how you access them when they've been sent to you. So there's a cookie manager. You can get through this as well. Using the HTTP base protocol filter, you get the cookie manager from it, and then when you new up your HTTP client, you pass that HTTP base protocol filter in, and then you can start working with your cookies. So that's all really good stuff.
Makes sense.
This is the whole filter pipeline. So it's a very sophisticated object. It's not an object, HTTP client, it's a whole pipeline of stuff. So you can kind of plug into different parts of the processing pipeline, and obviously at its simplest you're just interested in making requests and getting responses, but the base protocol filter allows you, and you can write your own filters, and there are other filters, allows you to influence what happens with that request as well. And the obvious ones, I gave you a little example in that demo there, is about asking for the server, if it can, to send you compressed content. So here you are, you new up a HTTP base protocol filter, set the automatic decompression property to true, and then for good measure we're actually passing some HTTP basic authentication credentials. So you can pop a password credential, you can pass the credentials into that object as well. Then you can create, what you do is the key thing with connecting an HTTP base or any protocol filter in is there's an override of the HTTP client constructor where you just specify that. And then you just make your calls as normal, but the protocol filter is then in the pipeline and doing all its magic, including asking for compressed content and automatically decompressing it when it's received. So it's really cool and very flexible, and you can do a lot of cool stuff.
That is nice that you don't have a dot decompress. It's all handled transparently for you, the developer.
Yep.
That's pretty nice.
It is nice, yeah. Now I'm just going to wrap now. We're kind of out of time in this session, so just a quick word on identity and authentication, which is a shame because it's a massively important subject.
Of course.
So this is just kind of a high-level awareness kind of thing. So obviously most apps need it, and the paradox is that users hate signing on. Now we hear this, and we have made a lot of effort in Windows 10 as a platform to avoid these kind of issues where you're already signed in with credentials, and then you go to like a SharePoint site, and you have to sign on with your credentials all over again. Now there may be good security reasons for that, but there are occasions when you feel like you're being asked for credentials too often. And the way to try and tackle that is this idea of single sign-on, so that the whole system works as an integrated whole, so your web browser knows and your apps know who the identity of the user is, and that they're already signed onto the computer, and so they can get at those credentials and just get the tokens they need to access the resources in a secure way, but not to bother the user with popping up for credentials all the time. Now, there's couple of things that help here. First of all, Credential Locker is a roamed storage which allows you to, if you do need to ask for credentials and store them with your app, you can store them in this Credential Locker. We tackle this in the Connected Experiences module. You can find out a little bit more about that. But that's a nice way of storing them securely and roaming it across the different devices where your app might be running.
The takeaway is don't implement cryptography in your application just to store passwords. Not when the Credential Locker is here for you.
No, use the services that are provided. Now, many mobile backends, and we saw this actually with the Azure mobile apps backend that we started with this, support authentication, and you need to have authentication in your apps basically for personalizing the experience. So your backend needs to know who the user is,
right,
so that they can then divide the data. Because think of it, it's not like every user of your app has their own SQL Azure database. No, of course not. All the user's data is in one SQL Azure database, but you need to be able to identify each user so that you can you can tag their data with their identity, so that when they launch the app, they see only their to-do items and not everybody else's. So the story for doing that, of course, is to partition the data in the database by putting some kind of a user identity key into the storage. And then when they use the app, you need them to authenticate. So how can you do that? You could get them to authenticate against using their Microsoft account, or you could use popular, social provider networks like Facebook or Twitter. That's often
Azure
a common
Active
thing,
Directory.
or Azure Active Directory. So this is a very common thing, and typically the way this is done is you use this thing called OAuth to actually get the credentials. So you have a back-end service that OAuth is the process whereby you authenticate with it. And you have your app, and you start this whole thing by making an authorization request. You just kind of try and access the online service by using its URL. So you're just trying to call it. And what typically happens then is that the service will pop up a web page, a login page, where it will ask the user to enter their credentials. So the user then enters their credentials, and then the service will put up an authorization page. The user will typically, this is where you see the thing is, such and such a service wants to grant access to your friends and your entire life and this kind of thing.
Or your profile information.
Yeah, your profile information. So this is where the user has to say, yeah, I'm good with that. Mm-hmm. And then as the result of that, then the service will return to your app a token that says, yep, the user's happy with this, and here's your token, you can use this now. And you pass that token typically in the HTTP headers of every request to a REST service, and that's how the whole thing works.
Then it starts to work.
Then it starts to work, yes. Now, there's a lot, then you get data access, yeah. Now, you'd be right in thinking this kind of sounds like it's a bit of a long-winded and complicated process, and it is if you try and build it your own.
Yes.
So, and there's a number of problems with this. It's usually implemented with an embedded browser control, but it doesn't really support single sign-on. The credentials have to be entered into the application. It's complicated, so what the platform does is give you solutions that kind of encapsulate all that complicated behavior. Now, in Windows 8.1, we had this thing called the Web Authentication Broker, which did this on behalf of apps.
Yeah, we were definitely on the road to a better way.
Yeah, but we had other stuff for Azure Active Directory. There wasn't really any AAD auth built into Web Authentication Broker. So we had a kind of a disconnected experience. We had a number of different ways of doing this, online ID being another one. And these different systems that kind of all doing the same thing. What we've done in Windows 10, we now have this new API called Web Account Manager, which brings all of these together and gives you this great OAuth scenarios. And it's actually much better than Web Authentication Broker because it's baked right down into the Windows 10 OS. So this is where you get real user benefits, like when the user has logged onto their PC using their AAD credentials. So you've logged on with your Microsoft.com account or credentials or something. Then when you want to access some secured content that's on your intranet, you want to go to a SharePoint site or something, in the past you might have then had to re-authenticate.
That's right.
But now all the apps, the first-party apps and your apps that you write, using Web Account Manager, can sort of make a call to the Web Account Manager, say, I want to access this resource. Have you got a token? And it's all integrated, so you'll get an auth token straight off.
It's real single sign-on.
It's real single sign-on. So Web Account Manager enables apps and identity providers to plug into Windows 10 and provide SSO capabilities. It's really nice. The API is pretty simple. So there's a request token async, which potentially has UI if it needs to. So first of all, it'll look in its cache and say, yeah, okay, this person's already authenticated to this service. Here's a token. And if they haven't, then it will pop up the UI and make the user will enter their credentials, and then it will give you the token. There's a get token silently async, which is intended to be used from a background task or thread, which again gives you this gives you a token without any UI.
Obviously, you need to test it. There's no guarantee.
No, that's absolutely right. So this is you're assuming the flow that they've already authenticated in the past. And the output from that, it gives you back a web token request result, which encapsulates the token that you then need to present to the service. And you also get a web account object that gives you lots of information about the service that has provided that token. So it's nice and easy. This is a flow of this is the kind of thing of how it works. First of all, the web account manager, your app says to the web account manager, hey, I need a token.
That's the first thing.
Yeah, and then if it's got me, it will return a token.
That's
nice
the ninth
and simple.
thing.
Yeah, the ninth thing, yes. So you're probably picking up from this, there's more to this story. So the app then uses that token and gets the data using the token.
Okay, yeah, similar to OAuth.
Yep, exactly that. Now, the thing is, why that went 1.9.10 is because I just wanted to bring this into it. So obviously we provide already identity providers for Microsoft account and for Azure Active Directory, for the common auth providers. Now, other apps can also, like social networks and things, can provide, through the store, can issue apps that are identity providers. So these are just regular apps that the user can download, and these can also provide single sign-on to their web resources as well.
I see.
And the way this happens is that your app, you have created a web account provider app, and now the process from the client app's point of view is just the same.
That's the first thing.
First thing says, I need a token to the web account manager. At this point, the web account manager says to the web account provider, hey, I've got an app that needs a token. And the web account provider says, oh, have I got one of these already for this identity? Have I got one cached here, stored? And if not, then it will throw up the UI to the user to ask them to enter their credentials. So the user authenticates. You then, your web account provider app will go back to the back end. This is where it gets the actual token.
Sure.
Authenticates it. So the back end returns the token to the web account provider plugin, and that then will cache it and return the token to the web account manager.
Now you're ready to go.
Yeah, and now we're ready to go. So now the app gets its token. It doesn't need to know about the web account provider stuff. It just gets its token and gets the data.
Nice.
So
That's a
it's nice.
clean abstraction.
Really simplifies things from the app's point of view. And obviously, providing web account providers is a specialized thing. There's information online about how you do that if you run a large social network of some kind.
So we've been talking about building Windows 10 applications and leveraging the cloud in the back end. And we started with looking at what Azure Mobile Services, now called Azure App Services, can provide to you. And there's a lot of capability to build this out very quickly, as well as giving you this offline support using SQLite as your local database. Very powerful. We looked a little bit at the new client that we now have in WinRT, and how you can use that for basically everything.
Yep, everything. Does everything.
Yeah.
Makes the toast, makes the tea.
Makes the tea.
Scratches your back when you've got an itch.
And then we talked about how this new broker allows for a single sign-on. Obviously, we can't cover that broker in this session that quickly, but that's the gist of it all, and there'll be more information forthcoming with that.
Yep, great. Right, so we're going to take a break, and there's still more, so please join us for more, and we'll see you soon.
We'll see you soon.